So Fred and I had a lovely conversation at SQL Saturday Chicago. And I said, this is a session that you're doing. This is very interesting. And that there are other people north of your border that would like to hear about this. And so Fred said, sure, that he would present. And so I'm really looking forward to seeing round two of Big Data in the Modern Data Warehouse. Take it away, Fred.
Changed a little bit, yeah. Too. So I remember Gina really well because she's probably the most enthusiastic person about data that I've ever met.
We need to meet more
Like,
people in this community.
you were so into data. It's just like it's awesome, but need more people like you. But loved it, loved your enthusiasm, and I really appreciate you guys inviting me here. I'm so sorry I can't be there in person, but hopefully next time around I can start to. I don't know. I need a trip to Madison anyway. But like Gina said, we met at SQL Saturday in Chicago. I live in Chicago. I've been here for about 10 plus years. Um, and I work for a company called Aptitive. I'm actually a co-founder. So it's a data consulting firm. We basically do all things data. So be it data integration. This is my plug, by the way. And then I'll be done. Data integration, BI, application development, strategy. And the difference between us and like other consulting companies is that we just focus solely on data. So application development, we're probably not going to go develop like a mobile app for you for your for managing your website, but we might develop a web service that lets you hook up an API to your data warehouse so that other services can get access to it. So we start to see a lot of data structures and I guess all the solution areas merging a little bit, where data integration and app dev are kind of the same thing these days when it comes to data. And then BI just kind of encompasses that, and strategy does as well. So that's what we do. We're here in Chicago. We focus on the Chicago area market. Madison is so close that it's probably basically a suburb of Chicago. I know you guys. I just feel like I offended a lot of people by saying that. But we do solely focused on the Chicago land area and areas nearby. So myself, I've got about 12 or so years of hands-on development and architecture, and then 30 plus years of hands-on tech. So I'm not that old, but I remember playing with BBSs back in the day on my Atari ST and doing some like QBasic and Modular 2 and some other crazy stuff on my 1200 baud modem. So I get pretty geeky. And then just overall, I've been kind of reinvigorated with the whole pace of the technology in this data space. So this whole thing started when I went to PASS in October in Seattle to the PASS Summit. I'm not sure how many people were there, but man, it was cool. Like I've been going to these types of things for a long time, and there really hasn't been a lot of, I don't know, innovation around our space for a long time. So it's been just kind of, okay, write SQL, write a data warehouse, write ETL, put some boring business objects or reporting services report on it, and then go do it again. Because I've been in consulting this whole time, but I don't know, like all the stuff with Azure, all these cloud services, it's enabling some really, really cool things. And so I just took in so much information from the past summit, and I highly recommend anyone goes, but I took in so much info that I didn't even know where to begin. So I figured I'd just pick like some crazy buzzword and then get on my soapbox about it. And I'm not sure if everyone is muted, but I absolutely love interactive sessions. It's the best way to do these. So anyone who has experience with this, especially with a small group, anyone who's done big data or is building this kind of thing, I'd love to kind of, I guess, build this presentation with you. And I don't know, just kind of learn as we go.
Sounds good. We do have microphones, so we can pass them around.
Cool. And then if there's any questions, stop me. And I know, Gina, you can always just repeat it, and I'm happy to answer anything along the way. So big data by example. I heard this, I can't remember where I heard it, but it was the best example that I heard about big data. And so if you think about, and this will be the only thing about big data that I talk about in terms of like the generic, what is big data? How is it used for? It's more for, let's say you're doing like something where you're counting the number of people in the room. And let's say you have a really small data set, and all you want to get is like the aggregate. So you want to do a count of people in the room. So basically in SQL, select count of star from room. And if you have a small data set, if we're looking at like 20 people here, you've got one person who's going to use one CPU, it's one job, and it's going to hit it, and it's going to bring back the count pretty quickly. If you did that in SQL Server, even on the worst machine ever with like no RAM and just one CPU, it's going to come back pretty quickly. But if you're looking at the next one on the right, where you have a ton of different people, and you want to aggregate that, well, even if you're just doing a count of star, a regular relational database is probably going to be pretty good at that. But let's say you want to group it by different things. So I want to group it by number of people wearing a green shirt, or the number of people based on different attributes. So when you get into more unstructured data, where like Facebook type data structures, where some people might have where they used to live. You've got all the likes. If you've ever looked at their advertising, they've got a lot of data about you. So maybe we want to build a profile of all the people in the room, and we want to do that through some kind of query engine and store those aggregates somewhere. So show me the count of people wearing green shirts, and then show me the count of people with long hair, and et cetera, et cetera. That's where big data comes in. I guess the process becomes a little bit more important, because if you're trying to do that in SQL, it's going to chug along. You're probably going to have to make a couple different iterations, but if you get a couple different worker bees going through and kind of looking at it row by row, where one person is going to go count the number of people in green shirts, another person is going to go count the people with brown hair, and then you've also got someone going row by row doing all those things. Each one of those could be a CPU doing its own job, and then once they're done, they meet back in the middle and say, oh yeah, here's my count, here's what we got, and they go back and return it. And imagine doing that same big data type processing on the example where we're counting just the people in this room. If you want to have, let's say, 10 CPUs and 10 people do it, you're going to have to go through. Every person is going to have to count 1, 2, 3, 4, 5. Not even that, probably 1, 2. Go back into the middle of the room and then say, hey, I got 2. Another person comes by, yeah, I got 2. So latency has a huge impact on this kind of thing. You could return this in under a second in SQL Server or any relational database. You do that in big data, just count star. It's a pretty fun example to run, because it usually takes at least a couple seconds, depending on what platform you use. Does anyone in the room have experience using big data, like in the real world, aside from just playing around with it?
I see one hand raised. What's your experience? Well, I'm handing this back. I don't want to even say those words back. I'm going to say them wrong.
I worked at a research foundation, and we studied people's chromosomes and genetics.
Oh.
So, yeah, we used Netezza, which was a parallel data warehouse appliance.
That's awesome. So that's actually a very legitimate use for it. Yeah. So you're looking at tons of data with tons of different attributes, a million different ways, and it's probably not a trivial amount of data either. That's cool. My experience, and I mostly focus on mid-size to larger enterprise companies. So I work mostly in the enterprise space, even and then the startup space a little bit. But most of the bigger companies or mid-sized companies haven't really adopted big data yet, for I think reasons that are probably obvious to most of us in this room. It's kind of more yeah, we need big data, or a C-level person hears, yeah, we need big data, but there's not really an idea of what that really means and how does it fit into the bigger picture. And the goal of this presentation is really to help frame, at least how I think big data fits into the bigger picture when it comes to enterprise, not just proof of concept, pretty pictures, and using technology for the sake of technology. So again, I'm not gonna spend much time on this short history lesson, but when it comes to big data, it's just, to me, it's more an undefined schema or undefined data in large amounts of it, more so than the volume. If you hear a customer say, yeah, we've got big data, we got a lot of data, it's like 3 terabytes. That's not a use case for using something like Hadoop. Now, if you had that example with the analyzing genome data, totally different, because you're looking at all kinds of different things, and you don't always know what you're looking at, which is also important, something we'll get to. The idea also with big data is that you're scaling out instead of scaling up, so you're using a bunch of commodity machines. Just kind of back to that example of counting, you don't really need skilled workers to count. You can get anyone off the street, and hopefully they can count. But when it comes to doing some crazy processing with one CPU to be able to do, to count all that, it takes a little bit more brain power and energy to do that. Even though this is a Microsoft-centric group, I was pretty ambitious, and I'm going to try to I'm going to be using big data on Google BigQuery, just because I found it to be the most friendly when it comes to SQL development, and it also has the least amount of overhead. And they give, I think it's still 2 terabytes of free processing every month, and they have a bunch of cool public data sets, so it's fun to mess with. And it's really cool for demos, and it hasn't broken on me yet, which is nice. And just so people can kind of see what Google BigQuery is and what it's made up of, there's a couple different things going on. Again, this is just for background. There's a Google file system which really inspired the HDFS file system in Hadoop. For those who know it, MapReduce is probably a word you've heard before. It's not what BigQuery uses anymore, because Google, I think, came up with this idea back in like the early 2000s. So they've replaced that engine with Dremel, and internally they've probably gone on to something way cooler that they'll never tell us about until they're done using it. And then Bigtable is just a NoSQL and replicated structure, so allows you to scale out. So I could have the same data set that counted people across hundreds of machines, and with Google BigQuery, you don't even need to manage that, which is the nice thing with some of these cloud services. Most of us aren't infrastructure people, so we can't just spin up Hadoop servers, but we can write SQL queries that can do that in the background. And again, most of these are optimized for batch workloads. So if you want to do some real-time transactions, for example, if you have a reporting tool like reporting services sitting on top of Hadoop, that's not the best way to use it, because you're going to be running batch jobs like MapReduce, where it has to send out a couple different workers, however many workers you have machines, grab it, and then reduce it, so aggregate it, and bring it back into your report. Could have been way faster another way, and I'm going to hopefully show how we can do that. So just to drive the point home, this is kind of looking at big data querying versus typical relational querying. So big data, you could have those worker jobs, and you could even multiply that by 10,000 if that's what you want to do. With Google BigQuery, you don't really know how many workers they have running in the background, but it's optimized based on the query you process. So their query plan, execution plan, is based on what you write. It's also based on how much you pay, of course. So that gets you that will end up getting you the regular result. With relational databases, each query, unless you specify otherwise, is going to be just one CPU running a query engine to get you what you want. So in this example right here, the one on the bottom is the one I think would work much better. So where does big data fit? I think it depends who you ask. But what kind of inspired me to do this is prior to attending, or no, it was after attending the PASS Summit in Seattle in October. I went to a vendor meeting with one of the big data vendors, not going to say who, but someone in the audience at the very end of like this big conference asked the question, do I need a data warehouse, or can I just use you guys? And they're like, yeah, data warehouses are dead. You don't need them. Like, you can use us as a data warehouse. And this is just a Hadoop-based platform. And I had to hold my mouth, but I was like, well, wait, no, that's not true at all. It's the latest buzzword, but it's not going to replace a data warehouse. The data warehouse is still really great at things, and this is just the latest technology. We've been here before. We've gone through this whole like, oh, this is dead, let's move on to the next thing. And really what's always been tried and true is good enterprise architecture, and the relational database, it's been around for a long time, and it's just getting better. You look at SQL Server 2016, that's one of the most polished products I've ever seen. And I don't know, if you ever hear someone say relational databases are going to die in place of big data, they're crazy, in my opinion. So how do we help figure out where they belong? So this is kind of an architecture diagram for the projects I've usually been on, where you have a bunch of enterprise apps, so like a CRM, an ERP, and then maybe you have cloud apps, which these days, eventually they're probably all going to be owned by Salesforce.com. So I might just be able to relabel cloud apps as Salesforce. And you're bringing that into some kind of data hub or ODS where maybe you're making copies of the data, cleaning it up a little bit, and then maybe putting some kind of like business transformation logic around it so that you can reuse it and send it to other systems. And then from there, you're going to put it into your enterprise data warehouse in a structured manner. So if it was a typical sales thing, it's pretty straightforward. You've got you'll have your customers, you'll have your products, and you'll have your sales, and you can model that perfectly with a dim customer, a dim product, and a fact sales, and a dim date, and then you throw a report on top of it, and it gives you what you're looking for. And that's tried and true. The Kimball model is still fantastic, and it's what we use in most of our projects today. Actually, all our DW projects today. So what would happen if you took away that whole process into the enterprise data warehouse? Well, then you're back to that example where I was saying if you throw, I think Tableau supports Google BigQuery. So let's say you threw if you threw Tableau on top of that, it's going to have to issue like a batch workload process each time you run the report. So not only is it going to take a little bit longer than it would had it been just structured out, but you're also going to be paying a whole lot more money. So if it has to process a terabyte of data for each report, well, it would have been better to just take that big data and put it somewhere else and have your report run off that. So cost plays a big factor there, but so does latency and time, because most people, even 5 seconds waiting for a report to render could be the difference between adoption and not getting user adoption. And so you just really have to ask yourself, what are your use cases? Are these reports that are going to be run multiple times a day? Is it once a month? What are you trying to do with it? Is your front end reporting just data exploration, where you're trying to do things like analyze genome data, but you're not really sure what you're looking for? Well, that all plays a difference in what your end data structure is. So one size certainly does not fit all. Not every company needs a data warehouse. Not every company needs big data. Some need both. Some need to figure. In the end, it's the typical consulting answer, which is it depends. So you really need an enterprise architecture roadmap. And one thing I've seen at a lot of different places these days is the solution architect role is not always there. You might have an architect for one project or for one product, but one that's kind of overlooking the entire enterprise, especially as you're adding more and more specialized apps out there. With the cloud apps, other than Salesforce, you could have your own time and expense software. You could have an accounting software out there, GitHub. You could have all kinds of different cloud apps that are doing very specialized things. And one of the big areas where we're going to see a huge demand for IT services in our field, I think, is going to be around connecting all these cloud apps with your old ERP stuff. It was a lot easier back when everything was just running on a relational database. That's not really true anymore. You're going to have some that's running on its own proprietary thing. You're going to have some that you need to hit a REST API, and that's kind of where the whole application development piece comes in. So getting that data, doing something with it, transforming it, and putting it into whatever your end state reporting is. One thing that some of the tools that came out, I guess maybe the last 5 years that kind of changed the BI landscape, like Tableau, they kind of made the argument initially that, well, you don't need a data warehouse anymore. So that all that ETL, you don't need that. You can just connect directly. We have so many data sources you can connect to it. Problem that they found is that, well, now someone still has to do the ETL, but now it's the business user. Doesn't always make sense, and you lose that one version of the truth. And the data warehouse can come to help for that. So if you have structured data, you know what you're looking for. The enterprise data warehouse is the best place to look for that. What you're finding instead at a lot of places I've seen is that the cloud apps end up becoming a reporting silo. So because people want to be able to just go to one place, and because there hasn't been a lot of connection in terms of integrating cloud apps, like, again, Salesforce, a classic example. There hasn't been a lot of taking that Salesforce data and combining it with the data warehouse. You're actually finding the opposite, where they're putting data from their other enterprise on-premise apps into Salesforce and using Salesforce reporting. And it wasn't designed for that, and it's ugly, and it's not what we should be. I think everyone in this room knows that that's not what we should be doing. And I mean, we've been here before. Again, it's the latest shiny tool, and we just need to remember enterprise architecture and core solid enterprise architecture is important. And again, every use case matters. So what if you looked at it this way? So if big data, let's take an example of say big data is that genome data, and I know nothing about this field, but let's suppose you were combining it with ERP sales about gene therapy. I don't know. Let's say you discovered all kinds of super modifications that you could take for your person, and you found aggregates, and you've run all kinds of predictive analytics, and that's all in your big data Hadoop source. Well, once you've analyzed it, maybe you can classify it as here's the gene therapy we have for strength, and here's the gene therapy we have for intelligence, and here's the one we have for making people more robotic, and here's the one for curing stress. And you take all that, and you can, let's say you take aggregates of all that and how many successes you've had versus how many failures, and you combine that with your enterprise apps where you've got sales of your strength tonics and your intelligence tonics, and you've also got cloud apps, so your CRM apps telling you, here's the marketing campaign to sell the strength tonic, and here's the marketing campaign and contact and opportunity we have to selling these other ones. Combining that all together then into your data hub and ODS, putting that into the data warehouse, you could easily have a fact table built off that big data source, while at the same time throwing another data discovery tool, again like Tableau or Power BI, on top of your big data source, and kind of looking at it just to try to find what it is you want to structure. So again, it all depends on, is it structured or is it unstructured? Do you know what you're looking for, or are you just trying to kind of explore for it? And both of those use cases are really valid, and it's nice that we're starting to see some tools out there that support this kind of thing. With Power BI and analysis services, I see that as kind of one of the best examples of bridging the gap between the Tableau world and I guess the IBM Cognos and business objects world where we had before, where it was centralized reporting, IT controlled everything, versus today where versus the Tableau world where you're just kind of making your own things up and looking for things. But now we have this kind of centralized semantic layer controlled with the tabular model and analysis services, but you can also use Power BI to bring out your own stuff in. So I think Microsoft made an awesome move with that, and I never used to be a huge Microsoft fanboy, but they got me sold on this. And so to me, I see big data as just another data source. And to me, the question of, do I need a data warehouse? How do data warehouses replace it? What happens with the data warehouse skills, and what happens with our data warehouses that we already created and spent a lot of time on? They're still great. In big data, you just need a plan for what you're going to do with that data and how you're going to integrate it into your data warehouse, along with a data discovery path. So when we know what we're looking for, big data can just be another data source. Again, if you don't know what you're looking for and you're just going to load it in the data warehouse willy-nilly, you're not going to get the best results. So it makes sense to have a data discovery tool like a Power BI and a more structured semantic layer to control that one version of the truth. So the idea of BI can then be do your data discovery, figure out what it is you're looking for, have the IT team get the requirements for that, put it into the data warehouse, and now you've got a structured feed that can repeat the same thing for end reporting for some of the non-power users. And at that same time, you've got people doing data discovery on the big data sources, looking for all kinds of new trends and new things that we might want to report on. And I just see that as being the right path for implementing good BI, and you're taking less of the work off of IT in terms of coming up with requirements, but at the same time you're enforcing the good things about centralized IT BI deployments. Any questions so far? Thoughts? Arguments?
Yeah, I'm looking around the room. I think we're good.
Okay.
Let's keep going. Great.
All right, so BigQuery, I won't spend, again, a lot of time on this, but the engine is Dremel. It loves table scans. Google's idea with big data was, you know what, we're not even going to attempt to index things because who knows what the hell you're looking for. So it decided to optimize itself for table scans. So every query you run against BigQuery is a table scan. That's why when you say you've got a 2 terabyte processing limit per month for free on Google, it sounds pretty nice, but at the end of the day, you're doing a table scan every time. That's a lot of data. Like all the other ones, it's columnar storage. You don't need to keep chasing index and table optimization, and it'll run thousands of CPUs for a single query split evenly. And imagine trying to do that on-premise, which is the great thing about the cloud again. There's no way you could do that on-premise unless you want to spend all night, go into the junkyard, trying to find a whole bunch of commodity machines, throw them all up, install Hadoop on it, run your one. Maybe you just need one query, and then just throw them away the next day. Because that's kind of where this comes. You can write scripts that'll spin up what you need. Even on Azure, you can write a script that'll spin up your HDFS insight and run your query, and then shut it down right away. So I think that's kind of what we're seeing with AWS and Google and a lot of the other ones as well. So this is something I did in March. So it was the heat of the election season, and I didn't think this was going to be...
Hang on just a second. We got a question coming.
Sure.
Now can you hear me if I use this
Yes.
microphone? Okay.
Mm-hmm.
You mentioned Dremel. Is that a language that Google adopted or something that they created?
Oh, no, it's just the engine under the hood. So it's the way it's the algorithm that they wrote to do all the table scans and do everything in that little pretty picture below. So it's not a language. BigQuery itself uses like ANSI SQL, or pretty close to ANSI SQL, which is why I like it. So no need for most data people to need to know how to do it any differently.
And we had a question come in through the chat window as well. I don't know if you can see that or if you want me to read it back.
I can't right now unless.
Okay, then I won't worry. I won't make it switch. Okay, so Travis asks and says, we currently manage a fact table that has aggregates going back multiple years on a daily value for about 1,000 different patient care centers. We've been thinking about having this daily multiple site, multiple year aggregate job that takes many hours to run into a big data tool to crunch the numbers, and then throwing this data back into our data warehouse as an updated aggregate. Do you think that's the sort of thing that this solution that a big data solution would be good for?
Absolutely. Throw all the raw data at your big data solution, have it run its aggregates. If aggregates are what you're looking for and not the detailed data, if you're looking for detailed data, no, it doesn't make sense. But if you're looking for aggregates, like you were just talking about, perfect use case for it. Put it into a big data source and let it do its thing, aggregate it, and then store that in the relational database, because it can do that 1,000,000 times better than SQL Server could. So that was actually the best example. It's better than any I could come up with.
Oh, well, we'll have to have him email you the text then, so that you can incorporate
I
it in the
know.
presentation. And he goes, thanks.
So next time I do this, I'll just steal that one.
Yes, have a plant. Yep.
But with this Trump slide, I honestly did not think this was going to be topical after March, but here we are, and Trump is still topical. So I didn't need to delete this slide. I ran this on BigQuery again. Some of the cool stuff they have is some public data sets. So they have this thing. There's a project called GDELT. It's if you Google it, it'll probably take you right to BigQuery. But they basically track all the events that have happened from like newspapers around the world. So let's say someone writes a news article in the Chicago Tribune about Obama going to Vietnam. It's going to have a whole bunch of fields in there. It'll have the full text of the article, and it also extracts things like the location, the longitude, the latitude, people's names, so like actor 1, actor 2, actor 3. So maybe it was Obama talking about Trump to to John Kerry while he was in Vietnam. You'd have all three of those people, and you can kind of correlate a bunch of things. So rather than me trying to come up with a really cool use case, which if you Google BigQuery and GDELT, you'll find some really cool queries that people have written to do really neat things. But I did not do that. So what I did was just try to extract some of the common words for a given day. So I think this was the day of SQL Saturday, so sometime in March, and I was trying to find, okay, across all the news articles, what are people talking about in the entire world? And you can see Syria was a big thing. Zika was starting to pop up, probably going to be a little bit bigger now. Trump is still there. But this was using Power BI just to connect to, I think it was a JSON file extracted from BigQuery. So kind of neat. And now it's demo time. And again, anyone stop me if they want to see something cool or do something differently, or if I'm going off in my own world. But what I saw is Google added a new queries or data set called like popular names, or maybe it's not new, but I just noticed it. So it's got all the names in the U.S. from 1910 through 2013. It's basically year, gender, name, and then like count. So it's not a huge data set, but it's a great example for what big data is used for, because I'll actually just show the table. I don't think I've had a demo in the last year that didn't crash on me, so here's hoping for the best. And I'll jump back to this if we've got time at the end, but this is the coolest query I've ever seen. All right, so I've got this is BigQuery right here, really easy to use. You just go in here, you can do a select statement. Anyone who knows SQL, you'll be right at home here. And they keep adding more and more. One thing that they didn't used to have, but they added at popular request, was select star. So they removed the star because some of these tables are gigantic. And if you did like a select star, you might get way more than you wanted. For example, this table right here this is the GDELT one I was talking about. It is 137 gigabytes. So, and that's just the basic data. So if you do a select star, it's not gonna be fun. But you can do it. So what I did was I took this table right here, really, really simple, good for our purposes, and there's not a lot in it. It's 163 megabytes, not huge, but we can kind of see how fast this would be. If we were to store this in a relational database like in our SQL Server, does it really make sense? Probably not, unless we need those details. Do we need to know that the name Annie was there in 1910 12 times? For this use case, probably not. So my use case that I'm pretending is that I'm a marketing company that makes, I guess, trinkets that have names on it, and I want to see what I need to make, or I want to market to certain people based on certain things. I've seen a bunch of Facebook ads pop up where they've got like a T-shirt or some kind of trinket with your name on it, And it's not that hard to do because they know your name on Facebook. It's an easy ad. But I saved a query here. One downside with this and anything Google is that the UI is always like a secondary thought. Yeah, so we've got this popular names query. So all I'm doing is selecting year, the sum of the number, and I was doing it where it's my name, Frederick, and I get that back pretty quickly. I can also do it to be a little bit more complex, so I can do the name, or name, take that out, and then we'll group by year. So you can see the SQL, you'll feel right at home. This limit one is pretty useful because this is how you don't go over your quota. So it means it's not going to give you anything more than 100 results. But if I run that, it's going to issue in the back end. The Dremel engine is issuing tons and tons of queries, so we don't really know how it's structured, but maybe they have a machine that has every single year on it. So maybe 1 year for 1910, one for 1911, etc. So it came back, processed 142 megabytes pretty quickly in 14 seconds. So I've got this aggregate now of data by year, by gender, by name, and then the number of people for that entire year. And so I can store that into my own little table, which is what I did. So I've got a table here that did that. And because Power BI doesn't support directly connecting to this yet, I had to export it as I think I had to do a CSV because Power BI's JSON support is kind of wonky right now. But you can export that, take it to your Google storage. I grabbed it here, so I've got it in a bunch of different formats. I tried to get really fancy and use Azure Data Factory to move it over, just so I could show that vendor lock-in is not really an issue unless you make it one. And vendor lock-in is bad. So having the ability, Microsoft's new approach of being able to work on any kind of platform, the fact that they're doing Linux SQL Server, it shows that it's a new company. So I kind of wanted to show, if I had a longer demo and more time to do this, I would have tried to do something like Azure Data Factory to load from Google BigQuery into like an AWS database and then have Power BI read on top of it. That would be like the perfect demo if I had time to do it. And it's totally doable. You can do it. So what I did, though, is I exported it and I loaded it into Power BI. And so now I've got this data right here, just loaded as a JSON. Are people in the room familiar with using Power BI or seen it at least?
Sorry, turn on the run button. Yes, they have seen it and love it in varying forms.
Okay, yeah, it's got some really weird quirks, but it's getting there. Like where it's at right now compared to 6 months ago, it's huge. So this is a dashboard I put together this morning. This is what I love about Power BI. You can do something like this in like an hour. So I just took that same data set that we extracted from BigQuery, and now this is no filters, but we're looking at everything. So this is basically number of people that have names per year, or number of unique names, I think. Not really that exciting. But then maybe we can filter by male. And then suddenly you can see over time, Michael is the most popular name, William and John. These are the most popular names from 1910 to 2013. But let's say I wanted to do, we'll do Gina. And so Gina, you can see, he's kind of, yeah, he kind of declined.
Terrible idea.
And you can see a running total of how many Ginas there were in the world. I like this visual. So yeah, the number of Ginas it didn't really grow that much after the 80s.
Bad investment. We have a question from the chat window again, if you've got time.
Sure.
Okay, so another question from Travis. If I wanted to import raw detailed data from a relational database into the Google BigQuery cloud service, what does that process look like? Can you automate it? And then can you get that result set back out?
What does it look like? I don't think it's that fun. Google does have the ability to do that. They've got a data loader, and you can do it through like CSV. You can also do it relational. If you want to get crazy, I'll actually just show a slide because I did do this. You can use SSIS to query directly from BigQuery or to load into BigQuery, and it's an ODBC source. So the name of the driver is Simba BigQuery, and again, it's ODBC, but you can connect directly to, as you can see right here, if I zoom in a lot. I did actually do this. I don't have it on this machine right now, but I loaded from a table that I had already loaded from BigQuery, so I had a job that ran. It was giving me the words by country for every night, and it was running nightly. And I could also take it from this SSIS package, load it into my data warehouse. So in the end, you get this right here. So I was doing aggregates from BigQuery, batch, nightly, load into the data warehouse, magic. So yeah, getting it in and out is easy. That's one way to do it. But you can also use Google's native tools. Again, they tend to be more like developer focused, which is the problem with a lot of these big data tools, is that you need to know application development. Not the problem, but kind of where we're going and the skill sets we need to learn. But yeah, it's easy to get in. It's just not a great GUI or a great experience. Okay. So yeah, I mean, this is the fun one. You can. I'm trying to think. I just had. So my daughter is 2.5. So I'll look her up, Claire, which is one of those old names. Give it to me. Okay, maybe it doesn't exist. Wilfred. Oh, I think I've still got a filter on. Yeah, this is so much data that it's probably. I'm going. Oh, there's still not a Claire. But let's do Fred.
I think you have to switch your gender filter if you're going back to Claire.
Oh, I didn't realize it. I clicked too fast. My laptop is not keeping up. There we go. So, makes sense, right? I picked a name that was not popular until just now. I just threw this in here because I thought it was a pretty cool visual, but you can use it to slice. I'm totally putting my laptop through hell. But yeah, you can use it to slice data to kind of get the same thing. Although apparently it doesn't reflect it up there. But yeah, I mean, this was a really simple demo I could do to do really powerful things. I've done something similar for that using the public GDELT data, and it's fun, it's easy to use. But imagine if you had this sitting next side by side with sales, so this number of people per year, and we were looking at, let's say, Michael.
We have a suggestion for Chris from the chat window. There's a Chris who's curious about his popularity.
Oh, to see his popularity. Let's see. We want Chris or Christopher? We'll go Chris. Big decline, but it's probably because it's Christopher. Yeah, this is a custom visual, so that's kind of the reason for the bugs. Any other questions about this? This is just kind of the fun thing, and you know, you can start to throw other things on there. It'd be nice, like the real world application would be to throw sales on here, or maybe opportunities or prospects, and to start to see, okay, well, how are my Thomas shirts selling? How are my Thomas mugs selling? And how are my, you know, how many Marys do I need to produce, or how many Mary cups do I need to produce, given that, you know, the total population is down to this. And that's where you start to combine some of that stuff together. So in the end, this is really what the enterprise version of the story is. If you can load that up. So manufacturing company has a lot of IoT data. They've got sensors, they've got environment sensors, and it's doing real-time monitoring. So as it's building its widgets, it needs to make sure that widget A, you know, met quality control. Widget B, if it didn't, drop it out, throw it away. If the temperature hits 100 degrees, sound an alarm and let everyone know that stuff's going to break. This is not happy. But that IoT data at an aggregate level might be pretty important. So you might want to know either by day or even by time. So take a dim time dimension and see by hour how many defects did I have, and what was the average temperature? Do we need to add more AC units in there? Things like that. You combine that with your ERP sales data, so you can see, okay, if my sensors and my IoT data was showing that our manufacturing defects were up 70% and our ERP sales data is down 20%, well, there might be a correlation. Your CRM, if you've got maybe a customer support thing on there or some opportunities, you might see, well, maybe we lost this opportunity because the customer was not happy with the quality of our products because there were too many defects or we had too many returns. Well, you start to tell a story then, and you put that all through your nice little SQL Server pipeline. Your ETL doesn't go away. SSIS sticks around. Your data warehouse is there. Your front-end reporting still does the same thing. And the Microsoft plug where they want to make all their money and where they're probably going to make a fortune is going to be on lots and lots of Azure services to support that. So, some machine learning, like, hey, we noticed if you increase or if you decrease the temperature of your environment, your defects go down like 20%. You might want to do that. So you've got now a machine learning service running on top of it, or data lake analytics, or if you go to portal.azure.com and just browse the number of servers there are, it's absolutely staggering. And I think that, as a side note, I think that explains the $10 a month per user price tag of Power BI, because it's there to get you hooked, and then once you're hooked, you've got tons of other stuff you can do to make it great.
Sidebar question for a phrase that showed up on the prior slide, data lake. I'm seeing that phrase showing up. Why are people saying data lake? What does it mean to you? Because to me it seems like we're pouring all this data into this big spot. I have no idea. Okay, is this a real thing or is this just a new term we're throwing around now?
Okay, so to me, we've always had a data lake, and it's this data hub ODS. To me, to vendors and the new buzzword, what it means is, just to kind of explain on Data Hub ODS, it's data that's been minimally transformed so you can reuse it later, or maybe it's been transformed into, let's say your product table is really based on 20 different tables. You might just want a table called product in your Data Hub that takes all those 20 tables, does the join logic. So when you take it to the data warehouse, it's a select star, but maybe you need to send it down to like another interface, like a flat file, or to back to one of your cloud apps like Salesforce. Maybe it needs to have the product information. You don't want to have to rewrite all that logic. So the Data Hub ODS is a great place to store that. Where Data Lake comes in from a vendor point of view, or at least from a Microsoft Azure point of view, is that it doesn't matter what your data source is. So if it's a blob, if it's like a PDF, so if it's an image, if it's a bunch of sensor data, if it's a bunch of JSON files from APIs, or if it's relational data, that all goes into your giant data lake. And how you use that, well, maybe you don't really know how you want to use it, but you might want to do some analysis on it. So maybe you want to see how the PDF contracts are tying to opportunities, but you don't want to build a real process around it yet. A lot of the data lake stuff, it's still in preview mode with that, with Azure, and some of the people at my company are convinced it's vaporware, but I haven't worked with it enough to know for sure. I tried to use it for this presentation briefly, and I couldn't get it working. So I was using Data Factory to copy from a data lake. It's in progress still. So basically, either I have no idea what I'm doing, or it's still not ready. Probably I have no idea what I'm doing.
Well, thanks for that. Let me look around and see if we've got other questions or comments. Yeah, hold on. Let me hand it. Oh, there's a microphone right behind you. Okay, hold on.
Yeah, it's on. Can you hear me?
Yep.
Okay. I've been to, millions and millions of conferences. It seems like where they just talk about the aforementioned data lake, and they talk about big data and this generalities that don't really apply to like business cases I've dealt with. But one thing that came up that you kind of mentioned earlier was like with BigQuery. One of our presenters was using BigQuery TDWI in San Diego, and he showed us like, if you selected essentially star from this table, star wasn't available at the time, but he selected every column.
Yeah.
And there was a cost estimator. I think the cost of that query was like $500 or
Yeah.
something like that. And
yeah, it's crazy.
And he was like, don't quite give this to sales yet. And I guess that's my
so
question
true.
is like, would you ever consider giving like, BigQuery as an analysis tool to like your marketing or sales folks and letting them like, do their analysis stuff? Or is that more left to a SQL developer or DBA to do?
So I'll speak to our company and then to kind of larger what I would advise for clients. So we're about 20 people. There is no way in hell I would give this to anyone. No way. It will, like you said, it will pop up and say, are you sure you want to do this? If you're going to do like some crazy query, maybe you're going to join all these tables together and do select star. But if I were a larger enterprise, I might give it to some like power users to use, but people who fully understood what they were getting into. As far as Google BigQuery, I'm sure there's a way to set some kind of spending limit and quota. Also, the way I would likely do it is to create my own tables. So this whole SQL Saturday schema right here, I created this on my own, and I loaded just subsets of data. So one of the nice things about some of the, let's see if I got my query history. Yeah, so a lot of the 486 queries, wow. A lot of the queries you run can be like separated by views. So you might just want to say, I want to get only like 1 day's worth of data. So it'll let you do subsets, so you're not querying the entire thing. But as far as opening it up to the entire world at your company, that's scary.
So the whole table scan thing, like, if I limit it to like 2014, data, you say it's going to table scan the entire data set, right? Or will that filter
Exactly.
not count toward my quota essentially?
If you use that limit, like if you threw limit 10, I think that will do it. I was trying to find, of the 486 queries I had, there was one where I forget how they do it, but it's something like, I think if you, let's see, I've got some saved queries here. Let's do my Trump one. Yeah, this is it. So see right here, this is an operator you can use on every data set. So you can say, this is in, I think, milliseconds in UTC or something. So you can say, give me everything from the GDELT database, but only look at the last, I think this is like the last 2 days or something, or maybe 1 day. And that makes things a lot better. So I would restrict it. But in general, with BigQuery, there's no way in hell I'd open it up to the world.
Yeah. Thanks.
Not yet. Sure.
I have a quick question for you. This is more of a theory question, I guess. I feel that big data is kind of like the wild, wild west. And do you have any? Well, first, would you agree with that?
Yeah.
And do you have any proof of return on investment? Any like websites that have like numbers that big data is actually making a difference?
Is it the wild, wild west? Yes, but if you look back 5 years ago, it's so much better now. There's some structure around it. Before, you had to know Java to even do anything. I think it's a lot better these days, and it's actually usable for data analysis folks and analysts. So it's getting better, but it's not quite firmed up yet. There's not a single vendor where I would say, yeah, I'm going to go with them and stake my entire company on it. I'm not at that point where I'm comfortable enough. And you still see new features pop up with all these as we go. As far as return on investment, I don't know, does a case study count? Yeah, I haven't seen, I know a lot of the bigger companies, like the bigger insurance companies and healthcare companies, they're using it, especially on the research front. But in terms of outside of like academia and research and proof of concepts, are they getting their money back? I really don't know. As a company, we don't deal with a lot of gigantic enterprises, but at the same time, I almost wonder if gigantic enterprises might be more dysfunctional when it came to big data, because I mean it is kind of the wild, wild west out there. So I guess where I would see the best return on investment would be on smaller prototypes and how you've integrated it and how you've actually made use of it with all your other data. Because I think the way most companies, at least that I've come across that have used it, the way they've implemented it has been in a complete silo away from everything else. It's just a Hadoop source. They're producing something off of it, and they're saying, hey, look how cool this is. It's like, yeah, it's cool, but what do we do with it going forward? What's our plan? What's our big data strategy?
Yeah, it's easy if I have my technology hat on to say, oh, this is great stuff, but then if I put the business hat on, it's like, well, how is it really going to help my business? That's the hard part.
I'm the exact same way. I basically have to. I'm the technology guy that wants to implement. Like, I would implement Azure Data Factory today if I could, but then I'm like, oh wait, I'm running a company. I can't do that. That would be crazy. So when it comes to like my data, I'm sticking to the tried and true right now. And if I ever do have a big need for big data, and as a consulting company, I don't know if I ever will, but I'm sure I'll have to build some just for fun.
Actually, I liked your example of the IoT and the sensor data. I wonder if that's going to, because sensors and your ability to get data from things is getting easier for companies. So I wonder if manufacturing will start playing with that some more.
I think you're exactly right, Gina.
We'll see. But as soon as I saw that slide, oh, wait a minute, this is perking up my ear. Okay.
I think you're right, and I mean, even if you look at Microsoft's Cortana Analytics case studies, it's all around Rockwell and using IoT. So I mean, that's the most data out there, right? I can also see it benefiting telecom companies. So I remember doing work at a telecom company before, one of the mobile providers, and we were basically analyzing data signals. So every single call that came in, every couple seconds, it would ping and say, here's my signal, here's my power level, here's like 100 other things about it. That was painful to write in SQL, and I don't think we ever really got it anywhere, but that would be a perfect candidate for this.
We have another one coming in.
Okay.
So no. Thank you. Source of data that is not as instant. This is another thing, is like a lot of times I think the demos and the prototypes and stuff, people are figuring it out, so they use a set of data that's pretty easy to access. But there's a huge amount of geographical data out there, and SQL Server is pretty amazing with what it can do, even though I don't think we hear a lot about some of the geo stuff. And then there's also a huge amount of data, demographic and census data that's publicly available. And again, It's a huge amount of stuff. I think companies could put together some of those sources that just aren't as easy to access, because you kind of have to build them, and then use this big data and know customers better and stuff like that, which salespeople would love. But
I think
it's
you're
just
right.
a learning curve there. I think that, in other words, that question to go, is this going to benefit me after I've built this? It's kind of a tough thing to go out on the limb and pull some of it together, but it's out there.
The question needs to always be asked: What do you want to do? What are you trying to do with your data? What are you trying to report on? I mean, if you were this is that example you brought up. It's great, like some of the public data. So this is like weather station data. I think there's one. It's broken out by like year, but if you look at it, it's just basically the weather station and a bunch of information about it. I'm sure there's some companies that can take advantage, logistics companies, to use this for predictive analytics and figure out, I don't know, predictive analytics for weather. I said that and I was like, that's probably not going to work. But looking back historically, how did the weather impact our the UPS deliveries? there's a lot of stuff out there, and ton of government data. Like even like Chicago does a great job. I'm not sure how Madison does, but they've got a great website with all their data out there, and it's fun for demos. You always see a demo here in Chicago using their public data, but I would love to see it combined, just like you said, with something that they're using internally,
Yeah, actually,
and not just for marketing.
somebody just posted the link for the City of Chicago data site right in the chat window. So
Yeah, it's awesome.
perfectly on point. Actually, another couple of good examples came in from the chat too. For big data uses, data streams for stock trading, and then analysis of web logs, other application log performance type
Oh,
data.
yeah. Weblogs, perfect use. I think that's exactly what it was built for.
Yeah, yeah, and then just Travis had a good point that so many companies are still struggling with data governance and definition and basic stuff that
Oh my
that
God.
big data just makes their brains fall out. So yeah,
Can you imagine trying to maintain something like that?
no,
Given that we can't even get people to enter in their CRM,
Right.
like
Exactly.
more than one, like the one company name.
right.
Like, come on, don't typo the company name. Just put it in once. Yeah, I mean, you got to get your data governance stuff together
Yeah.
before.
Yep.
That's a good point, though.
Yeah, or frankly, you just say, all right, you all are going to do a lousy job, so we're just going to have a way to analyze it that won't matter that you do a lousy job.
We're just gonna filter out like
Yeah,
the
whatever.
noise somehow.
Yeah.
Actually, if you can invent an algorithm that filters out the noise, wow, you'd be rich.
Yeah, well, Microsoft tried data quality services, and that plane didn't really get
Yeah.
off the ground. So
Yeah, we use it for one thing, for one very special
Yep.
use case.
Yep.
It works good for that, but
yep,
yeah,
that's it.
yeah.
Oh, having a little audio trouble. Hang on, just a sec. Okay, back to normal. All right. Other questions or comments from the room? I think we're in the room. I don't see anyone frantically typing in the chat window yet either. Oh, here's a YouTube video that we have to see. Don't forget the audience has remembered they were promised a movie.
A movie.
You said that there was the best something or other ever, and there was a video.
Oh, query. That's right.
Okay, there we go.
Okay. So I'm not gonna watch the movie. I didn't watch the movie, but I just saw this today. It was posted on. So Reddit is actually the best place I've been to for BigQuery. If you go to Reddit/r/BigQuery, they got some really fun stuff in there. So this has been a really interesting election, right? So if you've ever been to Reddit, you've seen the Bernie Sanders stuff, and it's its own. I'm not even going to get into it. It's its own thing. But this guy was saying, where were the supporters of the Donald Trump, Bernie Sanders, and Hillary Clinton subreddits 4 years ago? Like, what were they actively participating in? So this guy basically took all of the Reddit comments, broke it out by year, threw it into BigQuery, and then said, okay, show me all the subscribers and all the comments in these subreddits, and show me what they were doing back in 2012. And lo and behold, space, Occupy Wall Street, guns, men's rights, facepalm, conspiracy, Ron Paul,
That's
which is
great.
the Donald.
That's
So,
great.
I mean, the Sanders one with Occupy Wall Street makes perfect sense.
Yep.
Space,
Yep. Yep.
I don't know, but the Donald Trump one,
Yep.
love it.
Yeah,
And then Hillary Clinton is just like, yeah,
quietly
normal
there. Yeah.
stuff. Yeah. I absolutely love it. And this guy also then took Wikipedia. So Wikipedia is another public data source. So he took Wikipedia, combined that with everything just to see what the media attention was from Reddit, Wikipedia, and GDelt. And this took 5 terabytes of data, so don't run this if you want to do it for free. And then what were the most efficient candidates in transforming donations into delegates, and I don't know. This guy's blog is awesome. It's a lot of fun to watch. They do some really interesting and fun queries. Nothing that would actually relate to an enterprise, but it's on my list of daily reads.
Just trivially might relate to changing the word.
Oh.
What was that?
The comment was, oh, the election just might change the world. No big deal. No big deal. Just play with it. It's great.
Yeah. I know.
Cool. Last call? All right. Well, thanks, Fred. That was great. I'm going to see if the room can applaud and if the microphone will pick it up. Hey.
No, thank you so much for having me.
Thank you. We appreciate it. We hope we can come up sometime.
Yeah, absolutely.
Great.
So thank you so much.
Thank
Hope you guys enjoy the rest of your night and hope to talk to some of you after.
Sounds good. Thanks much. Have a good night.
All right.
Bye-bye.
Bye.